Every luthier and woodworker needs a solid workbench and cabinets to help organise the workshop and decrease clutter. In this first episode of the workshop build, I'm making 2 sets of each, from concept right through to the finished product. Episode 1 in this first season. My objective is to take an empty workshop and build it up in steps so I can share how-tos, blueprints, design files, and build videos, each step getting its own episode. This is the finished benchtop and cabinets, and also a Luthiers vise that we will build in a future episode. So let's go back in time to day 1 of the workshop. Rewind to late 2017. All of my tools are in boxes, and I took the opportunity to upgrade a couple of my machines. I need a dust extractor, so I got one of those, and I needed a bigger bandsaw, so I got one of those too. I decided to build 2 benches, one across the back wall and one to act as an outfeed for the table saw. The back bench design has a height of 930 millimeters, a width of 600 and a length of 3030. The front bench design has a height of 930 millimeters, a length of 2,200 and a width of 1,385. I can't draw, so my first move is to jump into Rhino and create a very boxy and quick virtual workshop in order to work out my dimensions. This is my CNC machine, a little kitchen cabinet I use for CNC type things. My table saw is here, and over on the other side is a seat I designed, but won't use because I got carried away. In future episodes, I'm going to do a walkthrough on how to build a guitar in Rhino and how to sand and carve it on the CNC I use. But for now, we'll leave the design process for later. The outfeed cabinets are 4 on each side, and the back cabinet is a 4 right now, but will eventually have 5 doors as it's so long. If we go into our top view, you can see I've exploded the design elements into a 2D cut list for each cabinet. I had some space on my sheets, so I snuck in the components for a dust cyclone system that we can cover in another episode. These files have changed a lot over the time that I've been working on them, as you would expect. So all of the information like dimensions and little notes that I had written to myself in the past, they're mostly gone now. But it allowed me to create a cut list, and I then took that cut list and sketched it out onto some paper. So while I already had all of the information I needed in Rhino, it's great to have a hard copy you can take into the workshop and change values on the fly if needed without filling your laptop up with sawdust. So here we go. We finally got a sheet of material out, and it's covered in truck exhaust. I've put it up on some milk crates because I'm making my benches. I just have to use what's lying around. If you're just starting out, I can't stress enough the importance of owning precision rulers and also precision squares. When you buy a ruler from one manufacturer and hold it up against another, you may be surprised to see they don't match up at all. Because everything in woodworking starts with measuring, it's better to buy a more expensive precision product than something cheap from eBay. Here you can see I'm measuring my pieces from the cut list, slightly oversized, because I'm going to be using one of these. This is a track saw, and it's not necessary for this type of job. You can use a jigsaw, a handsaw, anything you like. But because my table saw isn't set up yet, it doesn't have an outfeed. It's easier to trim things down to start with and then take them to the table saw to get dimensioned properly. So once the track is clamped securely to the workpiece, we can begin our cut. I don't like watching sped up time lapses, so this singular cut represents all of the cuts I made to get the sheet sized up ready for the table saw. I've had a lot of questions on Instagram about how to cut melamine without it chipping. It's pretty notorious for it, and there exist a few hacks, like placing tape over your lines first, or cutting in multiple passes. My way is to just buy a quality melamine blade, which is what I'm installing into the table saw here. This is a good place to drop a disclaimer. It's important to research workshop safety and not just put your faith in strangers on YouTube. Study up on the safe way to operate each tool you intend to use. One good example I can set is to attach my blade guard. This also helps to keep the workpiece held down to the table surface, so when you're working alone like I do, it's like having an extra hand, albeit one that's completely disposable. Okay, so it's time to trim the big pieces of the cabinets. You can see I have a temporary outfeed table set up, and also an infeed to help bear the weight of the sheet as I feed it to the saw, which leaves me free to make sure it's pushed up against the fence properly. I've carefully measured the distance from the blade to the fence, set the fence in place, and made a test cut on a piece of scrap to ensure the cut hits exactly where I want it to. I didn't enjoy wrestling with boards this size, but I really only need to do this once. Now it's time to cut the doors and dividers. You may remember they've already been rough cut with the track saw. Because of the way I had arranged them on the sheets, there are always two factory edges, so I'm using my precision square to find where they are so I can use them to run along the fence for a nice 90-degree angled cut. So, having identified my factory edges, I can now use them to run along the edge of the fence and make the cut. I've got around 4 cuts per sheet to make, and I've got around 33 sheets to put through, but once I've finished, I've got something that looks like this. All of the doors and dividers, as well as the backs. Now that we've come this far, I'm able to roughly sketch out the dimensions for the pine struts that will add some structure to the cabinets, as well as the pocket hole positions and the gaps for the doors. I'm using European hinges to mount the doors, and there are 3 types of hinge available, each with their own minimum clearances and mounting considerations. So it's important to do lots of drawings and get a firm grasp of how everything is going to come together. The pine has arrived, and it's a lot cleaner than the melamine was, which is great. Here I can use a simple speed square to mark my right angles and cut the wood to length. One of the things I'm making from the pine is the toe kick, so I have my dimensions here taken from the stock itself. Then I can measure up a template out of scrap MDF and cut the shape on the bandsaw. This template allows me to quickly trace the toe kick onto the cabinet dividers and will save a lot of time. You would never normally have this much of your bandsaw blade exposed, 1 for safety reasons, and 2 because it doesn't give you the best chance at a straight cut. But I'm wearing magnifying glasses here, so I'm actually a lot further away from the blade than it looks. And because the MDF is so thin, I'm not worried about the blade twisting. Now it's cut, it has 2 jobs. The first is to act as a template to space the fence and the blade. The other job is to trace the toe kick onto the cabinet dividers, so they're oriented properly and won't be cut incorrectly. Now they're all marked up, so I can take them over to the bandsaw to cut out the toe kick segments. You can see I have my fence set up by using my little template that I showed you before, and I've also clamped a rudimentary fence to the bandsaw table to act as a depth stop. With this setup, I can perform all of my vertical cuts and then recalibrate it to do the horizontals. Here's a horizontal cut happening, and you can see how by doing just a little bit of preparation with depth stops and templates, how nice the results can be. The upper blade guides are hoisted up high in this case, just so you can see what's going on. Here are the corners all cut out, and thanks to templates and prep, they're all exactly the same. Now we've reached the exciting part, assembly. We're using hidden pocket screws and tight bond melamine glue. I'm using a Craig pocket hole jig here. I think it's the least expensive one they do. I've used it for a lot of my cabinet making projects in the past, so I've definitely got my money's worth out of it. I didn't want to buy their expensive clamps though, so I quickly welded a piece of sheet steel I cut with an angle grinder to a $10 clamp, and I've got the same thing. The melamine on the left is the back of the cabinet, and the melamine on the right is the right side if you're looking at it front on. First thing to do is use an offcut of the pine bracing and mark where the braces go on the inside of the back piece, so I don't put anything there that shouldn't be there. This shows me the space I have to work with along the edge. So I divide it equally for pocket hole positions. Then I repeat the process on the right hand side, but this time I stagger the pocket hole positions so we don't get any collisions. Then I clamp the jig into place, drill a set of pocket holes and repeat. Sometimes if I feel a lot of resistance against the bit, I'll pull it out to clear the accumulated sawdust, then drill to depth. The more expensive versions of this Craig jig have a dust extractor port, so let me know in the comments if you want me to design and share the CNC files and blueprint for an extractor port that you can make out of plywood. So I have all of my pocket holes drilled and I'm ready to join the two back pieces into one big piece. I've got my silicone brush, which is one of the best inventions ever. Glue can't stick to it, so once the glue dries you can just break it off. In this shot, I've already painted glue onto the right side piece and you can see I've put some paper down to protect the floor. Melamine's main component is chipboard, which is, as the name suggests, very prone to chipping and breaking. So I've over-engineered these cabinets a bit for just that reason. Once the edges are glued up, I move the pieces together. I'm not using any clamps because pocket screws are designed to pull workpieces together, eliminating the need for clamps. They do sometimes have a tendency to pull the workpieces out of alignment a little, so in cases where that may concern you, you may want to set up clamps, just to sandwich the pieces into place. This back piece will be completely hidden, so I'm not worried about it here. In this next clip, I'm taking one of the dividers and placing it right over the join I just made. I'm using a resawing jig to hold the divider up at 90 degrees. In a future episode, I'll do a walkthrough of how to make some cheap plywood angle brackets that you can make out of offcuts or scraps. I've just drilled my pocket holes and you can see the calculations I made to ensure all three groups of pocket holes don't run into each other. What I didn't film was running a glue line along the join, then placing the divider over it, but there is glue under there. It will be a really strong joint with 2 glue seams and 3 different sets of pocket screws, pulling it all together from 3 different angles, 4 if you count the bench top. Basically what we're trying to achieve here is a big box subdivided into 4 or 5 smaller boxes, then the workbench spans the whole top, connects it all together and stops it from twisting out of square. I started with an internal divider, so my next move was to attach an end piece, then of course the other end. At this point I'm ready to start mounting the toe kick, so I drill more pocket holes on the inside where they won't be seen and glue up the surfaces. The cabinet is on its back at the moment with the toe kicks up in the air. This makes it easier to work on them. I always prefer to work up in the air as opposed to on the floor, and I can enlist the help of gravity to help keep them in place while I'm mounting the lengths of pine. The toe kick pieces will run along the entire front of the cabinet at the bottom, so in a sense they are the structural front of the cabinet. Along with the back piece and ends, they form the rectangle of the cabinet shell. After driving the pocket screws in, the vertical component of the toe kick is installed. Because this is quite cheap pine, it has a definite bend in it. I'm using this to my advantage by facing it inward. This way, as I bring in new cabinet dividers, the pine acts as a clamp to hold them roughly in place. Then the dividers can be glued and screwed into the toe kick, giving the cabinet a lot of necessary rigidity. The pocket holes for the horizontal component of the toe kick are all drilled out, and everything is looking nice and straight. Now the pine piece is screwed in, so the toe kick is finished. From this point, I have to reinforce the dividers and end pieces, so I'm using more of the pine with pocket holes drilled into their faces and gluing and screwing these into the back and front of the cabinets. What I'm fitting now is the top back section. I've laid down a bed of glue and now I'm just dropping some pocket screws into the pre-drilled pocket holes to fix it firmly into place. Now I'm repeating on the back bottom area of the cabinet, laying down glue, squeezing the pine section into the gap and finally screwing the piece into place. Repeating again for the front bottom section, I've added the glue to the sides of the pine insert this time and I'm driving in the pre-drilled mounting screws. You will notice I've also attached the front top insert so this cabinet section is now fully reinforced. As I've moved down the line and reinforced some more of the dividers, I've come to a section that will live behind an existing cabinet, the little kitchen cabinet I pointed out near the beginning of the video that holds my CNC accessories. There's a small space just before that section left over that I don't want to waste, so I've added an extra thin cabinet in here too. In this clip, I'm attaching the bracing with glue and an air nailer. As I mentioned before, the cabinet is lying on its back, so after reinforcing it fully, it's time to pull it forward onto its base and drag it to its new home against the back wall of the workshop. You can see I'm previewing the benchtop material here while I bring the cabinet doors over for a test fit. It feels really great to have the bulk of one of the cabinets done. The other two cabinets will be mostly identical, although they will be shorter and they'll be placed back to back with one big benchtop mounted to the top of the both of them. I was inspired by a kitchen island I saw in a commercial kitchen and how 6 people could all do different jobs all on the same bench. It's finally time to mount the doors. Each manufacturer for Euro hinges has slightly different screw and cup spacings from each other, so something like a Craig jig might not fit the hinges you're using. I'm going to use a Craig jig to drill my cup cavities, and I made these for the screw placements. So the doors don't bottom out on the toe kick, I'm shimming them during installation with a piece of scrap 6mm MDF. I'd recommend using something more like 10mm, otherwise you may find you have to do a lot of door readjustments as the seasons change. These doors will mount to the end or to the divider to the left of them, depending on what's there. In this case, it's the far left end. Here I'm using my square to draw a line that will be where the middle of the hinge cup sits. I do this at each end on what will be the inside of the door. Then I use the square at 90 degrees to extend that line. The Craig concealed hinge jig has crosshairs surrounding the cup hole, so I can accurately line up my jig with the lines I've just drawn. I've neglected to do a full rundown on how the jigs I'm using work in the video, because I figure you probably don't care about all the little ins and outs of the jigs unless you own one, and if you own one, you probably know already, so in the interest of not boring you to death, I'm just concentrating on the build at hand. So here's the jig. I've lined up the crosshairs with the lines I just drew, and I'm using a couple of clamps to hold it in place. I've also elevated the door off the ground with some scrap wood so I can slip the clamps under. The other part of the jig is the drill guide, which clips into the base. Once I've rotated it into place, I can drill the door. This jig is made of reinforced nylon, which is very lightweight, but I found after using it quite a lot that it stands up to use really well. I had thought of making my own jig for this job, but sometimes when a tool doesn't cost the earth, I'm quite amenable to just paying the money and directing my effort to more pressing projects. I bought the drill I'm using 20 years ago for $10, so it all balances out. I've drilled both ends here, and you can see when the sawdust clears, it does a really clean job. The secret to installing these hinges is to take a piece of scrap with a factory edge to help line the hinges up with each other. You could use a wooden ruler instead, but nothing too thin, or the hinge will slip over it. These are self-centering drill bits, and they're perfect for drilling a hole for the mounting screws, using the hinge itself as a template. I forgot I had them, so now there's no need to use the little templates that I made earlier. The screws go in easily, and the door now has its hinges. Off camera, I repeat this process for the other 12 doors. Now I can bring the door over to the cabinet, and not forgetting to shim it underneath, I can use the mounted hinge to trace the screw mounting holes onto the cabinet itself. You don't have to be ultra precise with this because the hinges have a lot of inbuilt adjustment. I'm breaking the surface of the melamine with a very sharp awl, which is a tailor or dressmaker's tool. This makes it easy to drill freehand into the melamine. Without it, even a sharp bit could skate across the surface. So I have my drill, and you can see how the bit goes exactly where I want it to. I'm not worried about mounting these screws straight. I'm happy to just eyeball this. I could also use a depth collar on my drill bit, but I'm not drilling to full depth here, so again, I'm just eyeballing it. The last few millimeters of depth are drilled out by the screw itself. I've only drilled 4 of the 8 screw holes. The idea is to mount the door with just those, then use the hinge as a template for the rest while it's in place. Don't forget to ensure your door shim is still there, otherwise you'll have to do all of this all over again. You probably saw something flying off the hinge. Those are the covers. They're press fit on with 2 flimsy tabs, so my advice would be to remove all of them when you're unpacking them and then fit them again once the hinges have all been tuned. I've used the 4 mounting holes to mount the door, removed the shim, and now I can use the hinges as templates to mount the rest of the screws. This is the part where we close the door for the first time and see it doesn't work. Don't panic, this happens to everybody. As I mentioned previously, there's a lot of adjustment in these hinges, so all that needs to be done is a quick tweak with a Phillips head screwdriver, and then the door will sit nicely in the cabinet. This screw I'm adjusting dictates how close to the cabinet the door sits. Right now the door is way too close to the cabinet, which is stopping it from closing. So I have to loosen the screw, push the door out to where I want it, and then retighten the screw. I'm happy with that for now, so I put the cap on and move on to all of the other doors. Once the doors are all mounted and quickly tuned, I can start putting things in the back cabinets at last. Also, it means instead of having to work on the floor all the time, I can work on this. Now I have to repeat everything I did on this twice to get my outfeed bench in place. At this point of the build, I have 2 sets of dividers and ends mounted to 2 backs, and the toe kicks are all installed. I cut some of the acacia bench top into a thin strip and ran it through the table saw. I wanted to get it to the correct height for use as a decorative face over the exposed pine bracing in the cabinets. You can see some I made earlier above the cabinet doors in the background. This next shot was before I'd covered up those pine braces. What I'm going for here is to fool the eye into thinking the bench tops are much thicker than they actually are. The reason I didn't just run the doors all the way to the bottom of the bench was because I wanted to be able to clamp things to the bench tops and still open the doors. This veneer is nice and thin, so I'm able to attach it quickly with the pin nailer. It's purely decorative, so there's no glue. I've mounted the bench to the back cabinets, and now my linisher, jointer, oscillating spindle sander, and my drill press all have somewhere to live. With the doors finally mounted to the outfeed cabinets, it's time to cut up and mount the bench tops. These bench tops are made of acacia wood, and they come in a standard 2200 by 600mm size. I'm using 2 full-size benches for the outfeed cabinet and part of another. The 2 main benches are getting one side removed, and the smaller part bench is getting both sides removed. So they'll all have nice flat sides to glue together into one big dance floor. Now that the outfeed cabinets are sitting there, I can finally use them for their intended purpose. I wouldn't recommend trying to wrestle with boards this big without a solid infeed setup or someone knowledgeable to assist you. The possibility of kickback is very real. I'm attempting to mitigate that by using my riving knife on the table saw and concentrating hard on not twisting the board once the blade is in it. Once the cut is started and the board is up against the fence, it all slides through smoothly. You can see my left hand is keeping pressure on the board, forcing it against the fence. I try to never stand behind the workpiece on a table saw, again to mitigate kickback, but in this case, in order to maintain even pressure on the bench top, I had to get behind it. Now I've got an excuse to use my glue caddy for the bench top glue up. If you want me to show you how to make one of these and provide all the blueprints and CNC files associated with it, let me know in the comments below. If you watch woodworking videos, you see a lot of these Bessie clamps for a reason. They're amazing. They're insanely expensive, which is why I don't have more, but I never thought I could love a clamp before getting these. They're super solid, which may lead some people to use that strength to squeeze the life out of whatever you're clamping. But it's important to not over-tighten your clamps, otherwise most of the glue squeezes out and you're left with a weak join. Here I'm using my silicone brush again and a product called a glue bot, which again is indispensable and quite ubiquitous within woodworkers' workshops. I had previously made one of these out of some plastic tubing in a Gatorade bottle, and let's just say I like this one a lot better. It probably looks very meditative and calming right now, but the truth is I was blasting Def Leppard in the background. If you were paying attention when I listed the cabinet measurements earlier, you'd notice that these benches are taller than the standard height of 850 to 900 millimeters. I'm 6'2", and I've found benches and machines in the guitar factory I used to work in were too low, to the extent I got injured from hunching down all the time. So this one is nice and tall, and feels really good to work at. My advice would be to work out what height you feel most comfortable with for your bench, or even with machines. I've raised my table saw and router table up on blocks too. Before gluing, I lightly touched the edges to be glued with 120 grit sandpaper to open up the fibers in the wood and give the glue something to nestle into. I apply almost no pressure, just let the sandpaper do its thing. Right now, you're probably wondering why I'm sprinkling salt on my glue, and that's a great question. Using salt as a soluble clamp is an old woodworker's trick. It stops the boards from sliding sideways, which is incredibly frustrating, and when the glue is dried, the salt is all dissolved. Also, it's cheaper than clamps, and it's never not worked for me. Here I am clamping what will be the center of the bench to the far side of the bench, which means the next part to be glued on will be positioned closest to the camera. I'm taking care here to get a good grip on the wood, but watching the squeeze out to ensure I'm not clamping too tightly. I've started with the two outside clamps, then tightening the two in the middle, then returning to the outside clamps to bring them to the requisite pressure and repeating for the inner two clamps. There was a bit of flex towards the middle of the glue up, so I shimmed up a couple of deep G clamps to hold the two work pieces so the top would be level all the way across. Now I have the exciting job of squeezing myself into each cabinet to screw in the bench top using pre-drilled holes. To make shelves, I simply cut some rectangles to fit the space and mount them by drilling holes in the cabinet sides, then sliding nails into them. Very low tech, but perfectly functional. This is my sanding tool cabinet, my sandpaper store, and one of my power tool cabinets. I haven't put shelves in most of them. In fact, I haven't even used most of them yet at all. I figure there's plenty of time to work out a system for all of my storage at some later stage when I have less to do. We've made it. There's one last job to do, and that is to oil the bench tops. To do this, I'm using a plain old paper towel and some inexpensive boiled linseed oil. The method is simply pour the oil on, then rub it into the wood with the paper towel until your arm falls off. You should keep rubbing until you feel the oil start to resist, then wipe off any excess oil from the bench surface. This shot is after the first coat. I ended up putting 3 coats down in all. It takes a lot of effort to get a good oil finish, so if you're in a hurry, there are all kinds of sealers and polys you can spray down instead. This oil smells pretty nasty, so I'm working with the door open. Oils with stain usually contain volatile organic compounds to help the oil dry faster, so if you're using one of those, definitely break out the respirator. When you're done, dispose of your rags carefully, as oil-soaked rags can and do spontaneously combust as they dry through a process of oxidation that produces heat. Well, the oil is dried, and this is as nice as these benches will ever look again. They were built to be used, so they'll definitely be chipped, scratched and banged, and that's all okay with me. The cabinets are rock solid, and I'm delighted not only with the clean look of the cabinets, but the warmth the bench tops bring. Now the machines I mentioned before and CNC machine are all moved in, with the spray booth just out of shot, this half of the workshop is complete. I'd like to thank you for joining me in this first episode, and hope to see you again in future episodes to make the sign on the back wall, the Luthiers vise, and all the jigs we're going to need to start making guitars.